I'm Randy Appel. I'm your Regents tutor. And in this lesson, you're going to learn everything you need to know about the behavior of gases. Now, the first thing you need to know about the behavior of gases revolves around the conditions that the gases are in. The conditions, one of the major conditions that you need to understand is standard temperature and pressure, STP. Whenever you see STP, you know you're dealing with standard temperature and pressure. It just means that's a specific temperature and pressure that the substance is in. So there's a certain temperature and a certain pressure. How do you remember the temperature and pressure? Well, you don't have to. The beauty is, just like a lot of other things in chemistry, it's right on table A, your reference table. It's specifically on table A, and that gives the value of standard pressure and the value of standard temperature in the units that you need to know about. For pressure, you need to know about two units. You need to know about kilopascals and atmospheres. So standard pressure is 101.3 kilopascals, or the equivalent in atmospheres, 1 atmosphere. For temperature, the standard temperature is 0 degrees Celsius, or 273 Kelvin, equivalent temperatures. Notice that Kelvin does not have a degree sign. Kelvin will never have a degree sign. We just put a K. We don't put degrees Kelvin or anything. So 273 Kelvin, 0 degrees Celsius. Now, one of the things you have to know about all this stuff is you have to be able to convert back and forth between Celsius and Kelvin and between atmospheres and kilopascals. Let's do the first one, the easier one, because it's on your reference table. Temperature. Converting from Celsius to Kelvin. What do? You go to your handy reference table and go to table T. So look at table T right now. And you see on the bottom of table T, it says temperature, Kelvin equals Celsius plus 273. So you're dealing with a formula, Kelvin equals Celsius plus 273. So let's say they said you have negative 27 degrees Celsius, and they want to figure out the Kelvin temperature. Well, you set up the equation. Kelvin equals Celsius plus 273. So Kelvin equals negative 27 plus 273, which equals 246 Kelvin. You also may have to go the other way. Let's say they said convert from Kelvin to Celsius. Let's say they said you have 125 Kelvin and you want to convert it to Celsius. So 125 equals C plus 273. Subtract the C from the 273, from both sides. And 125 minus 273 is negative 148 degrees Celsius. Now, one thing is worth mentioning is Kelvin. 0 Kelvin is the coldest possible temperature that could ever exist. And that's called absolute zero. Nothing will get lower than 0 Kelvin. Therefore, there's no negative Kelvin terms. The 0 is the lowest. The next thing you need to do is be able to convert back and forth between atmospheres and kilopascals, the two terms of pressure. How do you do that? Well, there's nothing on the reference table, unfortunately. But what you can do is you set up a basic ratio. You know that for every 101.3 kilopascals, you have 1 atmosphere, because they're equal. So let's say they say, if I have 45 kilopascals, how many atmospheres do I have? Well, you set up the ratio. 101.3 kilopascals is 1 atmosphere. So kilopascals are on top, atmospheres are on the bottom. Equals, and now you put kilopascals on the top again and atmospheres on the bottom. So 101.3 over 1 equals 45 over x. And you cross multiply and you get 0.44 ATM, as you can see on the slide screen. So that's how you convert back and forth. And you can convert from atmospheres to kilopascals too. The one thing you have to make sure you know is if kilopascals are on top in one side of the equation, they must be on top on the other. If atmospheres are on top, that's fine, but then they must be on top on the other. So you have to keep that consistent. When we're talking about gases, the most important thing about gases is the kinetic molecular theory of gases. The kinetic molecular theory is a way to explain the movement of gases, the gas particles. And there are a couple of the rules to the kinetic molecular theory. The first one is in terms of the movement of the particles. Gas particles, as you could see on the slide screen, you see the gas particles moving. Now they're moving, and there's 3 ways to describe it. They're moving constantly, so constant, random, straight line motion. What does that all mean? Do I have to remember all that? Well, just think about it. They're constantly moving. Notice they're not stopping. They're constantly in motion. They're moving randomly. We don't know where they're going. They could be going here, there. They're just going all over the place, but it's random. And they're moving in straight line paths. They're not moving in curved paths or windy paths. They're moving in straight line paths because that's the movement of gas particles. The next thing you need to know about gas particles is their collisions. Now, they're colliding with the walls of the container. They're also colliding with each other. But what happens is when they collide with each other, you have to understand that even though each gas particle has a certain amount of energy, so even when they collide with each other, they may transfer energy, but the total amount of energy remains the same. For example, let's say I have these two gas particles. Okay? Gas particle 1 and gas particle 2. Let's say each gas particle has 50 joules of energy to them, which is pretty normal. 50 joules and 50 joules for a total of 100 joules. Now, they collide. But when they collide, this particle transfers some energy to this guy. That's okay. So now this had 50 and this had 50. Let's say this guy transferred 10. This guy transferred 10, so it now has 40 joules. This guy would then pick up the 10, so it has 60 joules. 40 plus 60 is still 100. So even though there was a transfer of energy, the total amount of energy remained the same, and that's called an elastic collision. When the collisions result maybe in transfer of energy, but the total amount remains the same. The next thing, and the most important part of the kinetic molecular theory of gases, are the volume and the attraction of gases. The kinetic molecular theory says gas particles have negligible volumes. Negligible? What is this, SAT class? Negligible, you just need to know, means insignificant, almost no volume. So they're saying gas particles have basically no volume. And they say gas particles have no attraction to each other. So gas particles have no volume and no attraction. They go all over the place, and they don't actually attract to each other at all, according to the kinetic molecular theory of gases. Now, we have to talk about any gas that follows all of those kinetic molecular theory rules. So they move in straight line, constant random motion. They have elastic collisions. They have no volume, and they have no attraction. Any gas that does those four things is called an ideal gas. You know how many gases are ideal? 0. Not one gas is ideal. Why? Because real gases do have some volume and do have some attraction. So the kinetic molecular theory says gas particles have no volume and no attraction, but real gases do have some volume and do have some attraction. One of the things you have to know is when do real gases act most ideal? And the easiest way to think about this is think about it. Ideal gases have no attraction. So how can you get a real gas to have no attraction? Well, you have to change the conditions of temperature and pressure. Let's say you have the gas particles and you want to change the pressure. Here's the gas. If I increase the pressure, what's happening to the attraction between them? They're getting closer and closer together. Now there's attraction between them. But we want particles to be most ideal, so we want no attraction. So what we're going to have to do is we're going to have to decrease the pressure. So now the gas particles can spread all over the place. So the gas particles, the low pressure makes them most ideal. And how about temperature? Remember, we want them spread out, so we have to increase the temperature. If we increase the temperature, the particles move all over the place. Now you could memorize it, high temperature, low pressure, or you can understand that gas particles, you don't want them confined, you want them to be able to spread out. And the way you get that done is by increasing the temperature and decreasing the pressure. Now, the gas laws. There are 3 gas laws that talk about the behavior of gases and how they're changed by certain conditions of pressure, volume, and temperature. The first one deals with pressure and volume. Let's think about it. As I increase the pressure on a gas, what's happening to the amount of space it takes up, the volume? It's getting a lot smaller. So as you increase the pressure, the volume goes down. And it actually turns out that if you double the pressure, you actually halve the volume. So that relationship is called inversely proportionate. Volume is inversely proportionate to pressure. Now you may be thinking, oh God, how am I going to even remember all this? Volume is inverse to pressure? Very simple. You just need to know what a VIP is. Very important person. What does that have to do with chemistry? Very important person? Nothing. But VIP doesn't mean very important person in chemistry. What it means is volume is inversely proportionate to pressure. VIP. So now you know that volume and pressure have an inverse relationship. And you have to be able to graph an inverse relationship. And as you can see on the screen, the graph of the line as pressure increases, volume decreases, it's a curved downward line, and that represents inverse proportionate relationship. The next gas law deals with temperature and volume. Temperature and volume, as you heat something up, the volume actually expands. So as you increase temperature, you increase the volume. So there's a direct relationship between temperature and volume. How are you going to remember that? Okay, I remember VIP. Oh, wait a minute. How do you watch TV at home? What's the company you use? Do you use DirecTV? Well, DirecTV doesn't mean, it's not a cable company in chemistry. DirecTV means there's a direct relationship between temperature and volume. And again, this is just another neat Regents tutor trick to help you remember the gas law. There's a direct relationship between temperature and volume. As temperature increases, volume increases. As temperature doubles, volume doubles. And that's the relationship. And the graph is the opposite here, except as you increase the temperature, the volume increases. So you see a straight line going up. And the last one is temperature and pressure. And I know now you're waiting, you're like, oh, the Regents tutor is definitely going to teach me this great relationship between temperature and pressure. Unfortunately, for temperature and pressure, you just got to go on your own. Maybe direct TP. You just have to know that temperature and pressure have a direct relationship. If you increase the temperature, you increase the pressure. Now, it's important to remember when you're doing these laws that if you increase the temperature, then the volume increases, which would then decrease the pressure. No, don't even think about it that way. If you increase the temperature, you increase the pressure. You're assuming the volume remains constant. So you don't even worry about the volume when you're doing the temperature and pressure law. As temperature increases, pressure increases, and you can see the graph is a direct relationship. And the last thing we have to go over is the combined gas law. The combined gas law goes over math problems. So remember when I said as the temperature doubles, well, the volume doubles? So if it's 20 and to 4, bottom line is, if the temperature doubles, the volume doubles, you have to sometimes figure out, so they give you temperature, then they give you a new temperature. So let's say the temperature went from 20 to 40 Kelvin. The volume, if it was 10, would then double to 20. But you don't want to start thinking about it. You probably lost me already. What you want to do is you want to use the combined gas law formula. Uh-oh, another formula. Don't worry about it. Another formula that's right on the reference table. Under gas laws, you go to table T, you see P1 V1 over T1 equals P2 V2 over T2. And that just means the pressure times the volume over the temperature is equal to the new pressure times the new volume over the new temperature. A couple of things to keep in mind. All these laws that deal with temperature, and especially the combined gas law, only deals with Kelvin temperature. So whenever you see Celsius and you're doing a math problem, you must convert from Celsius to Kelvin. Also, if they give you, so you see combined gas law, you have pressure, volume, and temperature, and then a new pressure, volume, and temperature. But let's say they say the temperature remains constant, which means the temperature is not changing. So instead of using that whole gas law, P1 V1 over T1 equals P2 V2 over T2, you just take the temperatures out of the equation because they're constant, and the new formula becomes P1 V1 equals P2 V2. And anything that remains constant, you drop from the equation. Now, we'll do a problem. The first problem we'll do, let's say the problem said this. The volume of a gas is 4 liters at 293 Kelvin and constant pressure. Okay, light should go on your head. Constant pressure, pressure is no longer part of the equation. For the volume of the gas to become 3 liters, the Kelvin temperature must be equal to what? So you set it up. P1 V1 over T1 equals P2 V2 over T2. Pressure is constant, you take those out. V1 over T1 equals V2 over T2. V1 is 4, T1 is 293. V2 is 3, T2, that's x. We don't know that. We cross multiply. Right? 4 over 293 equals 3 over x. 879 divided by 4 represents 219.75, and that's the new Kelvin temperature. Some of the things the Regents does that actually is actually a little confusing to some students is they don't even give an answer like 219.75 for that kind of question. They actually give you 4 answer choices that have the setup to get 219.75. The Regents Tutor advice for a problem like this is you find the math answer, you do it like I told you, 219.75, and then take all 4 math answers and figure out which answer represents 219.75. And you'll see that it's answer choice number 2, because that gives you 219.75 when you multiply it out and divide it, and the other 3 do not. And I'm going to give you one more combined gas law problem, because this one's going to use all 3 terms, and then you're going to really be a pro. And the question is this. The temperature of a 2-liter sample of helium gas at STP is increased to 27 degrees Celsius, and the pressure is decreased to 80 kilopascals. What is the new volume of the helium sample? You set it up the same way. P1 V1 over T1 equals P2 V2 over T2. Okay, well, the V1 is 2. But wait a minute. What's the P1 and T1? Oh, it's STP. Oh, we go to the table A. STP. We know it has to be in Kelvin, so 273 goes right on the bottom. But what kind of pressure do we use? Do we use 101.3 kilopascals or 1 atmosphere? Well, since the other part of the equation shows 80 kilopascals, we're going to use the kilopascals, 101.3, to be consistent. So it's 101.3 times 2 over 273 equals the new pressure, 80 kilopascals, the new volume, which is X, and the new temperature, which is 27 degrees Celsius. But wait a minute. Do we do 27 degrees Celsius? No, because it has to be in Kelvin. So we convert it. K equals C plus 273. K equals 27 plus 273. That equals 300. So now the equation looks like that. You do the math part of it. Do your cross multiplying and all your mathematics. And you get an answer of 2.8 liters as the new volume. And that's the combined gas law. And the last thing you need to know about gases is what happens when you have 2 gases at equal volumes and the same temperature and pressure. If you have 2 gases at equal volumes with the same temperature and pressure, then you have an equal number of molecules or an equal number of moles. It's very important you understand the fact that if you have 2 gases in the same conditions of temperature, pressure, and volume, then those 2 gases also have the same number of moles or same number of particles. Now, I hope you learned a lot about the behavior of gases. We went over a couple of things. It's real important that you understand everything I talked about, but even more important is going over questions. Make sure you go over all the questions on behavior of gases, and then make sure you listen to all the Regents Tutor explanations, because that's really where you're going to learn the most. Even if you know the answer, even if you think it's an easy one, listen to the explanations, because it will be helpful and you'll learn great tricks. Thanks for listening.